Algebra 1, 3-1, graphing linear equations. 3-1, graphing linear equations. Now, the first thing we're going to talk about is what is a linear equation. This is an equation that forms a line when graphed. And there's a form of this linear equation called standard form. And it looks like this: ax plus by equals c. A and b are not allowed to be fractions. And c, this is called a constant. And by that, I just mean it's a number. Okay, so we're going to talk about what is a linear equation. And so here are some examples of equations that might be linear or not. So this first one, a equals 4 minus 3x. Now, if I can use my algebra to make it look like this standard form, then I know it's a linear equation. So if I were to add 3x to both sides, then I would get 3x plus y equals 4. Just like this, ax plus by, there'd be a 1 right here, would be your b value, and then c would be 4. Notice there's no variable over here. Something x plus something y equals 4. Now this could be subtraction, but either way, this is standard form, so yes, this is linear. Let's look at another one. 6x minus xy equals 4. Now, there's nothing I could do this algebraically to clean this up. I have this x times a y, and I know that's not linear. This should be just a number times y instead of a variable times y. Let's look at a couple more. See? 2/5 x equals 5. This one's a little bit tricky, but this is how this one works. I've got to multiply everything by 5 so that this is not a fraction anymore. So I'm going to multiply both sides by 5. And I end up, so this is 5 over 1. So the 5's cancel out, or they become 1. And so then I end up with 2x equals 5 times 5, which is 25. Now this is linear because I assume that this is 2x plus 0y equals 25. And so yes, this is linear. Let's look at another one. Y equals x to the 5th power plus 2. Now see, this x is to the 5th power. This is not linear. So this is this would look something like this, like something like that. X to the 5th. Well, it would probably be up here, anyways. But whatever, doesn't matter. It's not linear. It's the line. It's not a line. And so when we're talking about linear, it forms a line when graphed. So this would form a line. We would graph a line. This wouldn't. This doesn't. And this would also form a line. This line would look something like this. This would be x equals 12.5. So I'd find 12.5 here, and it would look something like that. Let's keep going. I've got 3 more. E. 1/3 y equals -1. So let's multiply both sides by 3 again. Or 3, not again. So that would be 1/3 of 3 is 1. Y equals -3. And then we can say 0x plus y equals -3. Yes, this is linear. Let's do another one. Y equals x squared minus 4. Tell me, is this linear or not? Louder, I can't really hear you. Do it a little bit louder. Nope, this is not linear. This looks like a parabola. It's squared, so it's not linear. 1, 2, 3, 4. It looks like that. Not linear. And the last one, G. 4x equals -2y plus 8. So for this one, we can add 2y to each side. 4x plus 2y equals 8. Linear. Okay, so now we've talked about what's linear and what's not linear, or how to tell. Now, let's talk about what is an x-intercept, and let's talk about what is a y-intercept. So an x-intercept is the point at which the line crosses the x-axis. So the x-intercept is where the line crosses the x-axis. At this axis, y is going to be 0 at that point. So you're going to have your point is going to be your x value, and y is going to be 0. Next, for the y-axis, this is the point at which the line crosses the y-axis. And at that point, x is going to equal 0. You're going to have 0 for your x value, and then whatever your y value is. So that's the x-intercept and the y-intercept. Now let's look at them. Let's use them to graph a line. We're going to graph using the intercepts. And this is the best use of standard form of an equation. So if I have 2x plus 4y equals 16, this is standard form, ax plus by equals c. So we have standard form here. And now I want to graph this thing. And so what I'm going to do is I'm going to find the intercepts. So I'm going to start with a little t-table over here, x and y. At my y-intercept, x equals 0. And at my x-intercept, y equals 0. So I'm going to plug 0 in for x. 2 times 0 plus 4y equals 16. 2 times 0 is 0. So now I'm going to divide both sides by 4. Y equals 4 when x equals 0. So here's my point, 0, 4. Now let me find the x-intercept, which is when y is 0. So 2x plus 4 times 0 equals 16. Those go away. I've got 2x equals 16. Divide both sides by 2. X equals 8. So my other point is 8, 0. Now let's graph this thing. So 0, 4 is right here. 8, 0 is right here. And those are my 2 points. I can grab a ruler if I want to, or I can just try to be as nice with my line as possible. There's my line. Notice I have an arrow on each side of my line, and I have graphed my line. Let's do another example. 3x plus 9y equals 18. I'm just going to do the same thing I just did, starting with a t-table. I'm going to put 0 here for x and 0 here for y, and then I'm just going to plug in those numbers and get my answer. So if I plug 0 in for x, what do I get for y? 3 times 0 plus 9y equals 18. Those go away. Divide both sides by 9. Y equals 2. So I have a point that is 0, 2. And then I'm going to plug 0 in for y to find out what x is when y is 0. 3x plus 9 times 0 equals 18. 9 times 0 is 0. 3x equals 18. Divide both sides by 3. X equals 6. So I have a point that is 6, 0, and a point that is 0, 2. I'm going to graph my y-intercept first, because that's just the one that I did first. So when x is 0, y is 2, 0, 2. And then when x is 6, y is 0. This is my x-intercept. This is my y-intercept. 1, 2, 3, 4, 5, 6. There's my other point. Draw a line between them, or through them, I should say. And there's my line. So here's my y-intercept. That's where x is 0, y is 2. Here's my x-intercept, where x is 6 and y is 0. All right, let's have you do one on your own. 2x plus 4y equals 8. Let's have you do 2 on your own. Negative 5x plus y equals 10. Okay, so you've got these two to do on your own, and then we'll come back and we will we'll do them together. Go ahead and pause and do these on your own. Go. All right, welcome back. I'm going to do a t-table here. I'm going to find my y-intercept. That's when x is 0. Find my x-intercept. That's when y is 0. I'm going to plug in 0 for x. I'm going to do a little trick here. When I plug in 0 for x, notice 2 times 0 is 0. That just goes away. 4, then I need to divide both sides by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Now, I'm going to do the same thing. When I plug in 0 for y, those go away. I have 2x equals 8. Divide both sides by 2, and so I've got 1x. 8 divided by 2 is 4. So those are my 2 points, 0, 2, and 4, 0. Plot these guys, 0, 2, 1, 2, there we go, 4, 0, 1, 2, 3, 4, 0. And my line, these lines all look very similar, don't they? Remember to have your arrows, because these lines go on forever in both directions. Last one, x and y, 0 and 0. When x is 0, the negative 5 goes away, y equals 10. When y is 0, that just goes away. Negative 5x equals 10. Divide both sides by negative 5, I get negative 2. So I've got 0, 10, and negative 2, 0. Zero, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And negative 2, 0, 1, 2. There's my other point. And then I draw a line that goes through them both. Boom, I've done it all. All right, let's keep on moving. We've got a little bit more to go here. Not a whole lot. But we are going to graph using a table. So you may not want to use the intercepts, and you may forget how. That's okay. Just use a table. So here is an example, y equals 3x plus 2. And here's what our table looks like. X 1/3 x plus 2, and then y. And then your point, x, y. So we kind of have already done this, but this is kind of a longer version of it. So if this x is where my input, and I would input 0, let's say 0, 3, and 6. I get to decide 1/3, so I need to think of numbers that are going to be easy to divide by 3 so that I just don't make too much work for myself. So I chose 3 and 6 and 0. 3 numbers is a good amount to know what the line is going to look like. So then my table looks like this. I just plug in 0 for x, 1/3 times 3 plus 2, 1/3 times 6 plus 2. So 0 times 1/3 is 0, so I end up with just 2. And then for this one, 1/3 of 3 is 1. 1 plus 2 is 3. 1/3 of 6 is 2, or 6 divided by 3 is 2, plus 2 is 4. So now I have my x value, which is 0, and my y value, which is 2, 3, 3, and then 6, 4. So now I just graph this. One, 2, 3, 4, 5, 6. Zero, 2 is right here. 1, 2, 3. 1, 2, 3 is right there. And then 6, 4 is right there. Okay. And then my line goes through all of those. There it is. How about you try one? So you're going to have 2x minus y equals 2. And your table is going to look like this. Now, before we do the table, before I have you do the table, I'm going to tell you this table method is way easier if it's y equals something instead of all of this mess. So let's change this to y equals. Let's solve for y, and then we'll fill in the rest of our table. So I'm going to subtract 2x from each side. So I've got negative y equals negative 2x plus 2. I'm going to put the x as the term on the left, and you'll see why next lesson. But this is going to be a good habit to get into. Now this is negative y. I want this to be positive y. So I'm going to multiply everything, the whole deal, by negative 1. So I get y equals 2x minus 2. I've multiplied the negative 1 by each of these terms. Now I'm all set. I've got y equals 2x minus 2. So 2x minus 2 goes here, and then my y value, and then my x, y. So I'm going to plug in 0 is a good number to plug in. Oh, hey, you fill in the chart. Choose 3 numbers, fill in the chart, and then graph that thing. And we'll come back together after you've paused and done your work, and we'll see how you did. All right, so go ahead and pause and do this one on your own. All right, welcome back. I'm going to plug in, let's say, 0, 1, and 2. Okay, 2 times 0 minus 2, 2 times 1 minus 2, 2 times 2 minus, 2. 0 minus 2 is negative 2. 2 minus 2 is 0. 4 minus 2 is 2. So let's graph this. 0, 0, negative 2. I didn't fill in the rest of the chart. 1, 0, and 2, 2. So I've just taken the x value and the y value and put them together here as an ordered pair. So 0, negative 2, 1, 2, there's a point. 1, 0, right there. Look, that's my y-intercept, that's my x-intercept. Then I go up to the left, to the right 2, and up 2, and there is my third point. Draw a line through them. And that is what your graph should look pretty close to that. And that is the end of 3-1. Do a good job on your homework.